The formation of cylindrical components in industry is straightforward when the right machines are available. These road roller rims were produced efficiently and economically on a bending machine manufactured by Hugh Smith of Glasgow. This 300-ton machine is typical. The main roller, bending bars and hydraulic lever mechanism can be clearly seen. In vertical bending machines, the plate is fed by the main roller and is clamped against it by the hydraulic vicing rollers. The bolsters are set in holders or cradles which are bolted to the serrated face of the reciprocating beam. They can be adjusted within their holders for conical bending. The beam moves horizontally and bends the plate against the main feed roller. The various components of the reciprocating beam of a 300-ton machine can be easily identified. Set into the middle of the beam are the hydraulic vicing rollers. The position of the bolsters is adjusted according to the plate thickness and material to be formed. When the bolster has been repositioned, the setting is checked. Roller support tables are used for bending short cylinders in heavy plate. Where extra short cylinders are to be formed, an upper support table can also be fitted, as shown here on this Hugh Smith 1200-ton machine, bending a 3-inch thick plate for a gear wheel rim. Hugh Smith vertical plate benders incorporate a curve meter to give in-process measurement during bending. The linear reading on the digital display is easily converted to give the true radius obtained. On the more powerful machines, the top slab is hinged for easy removal of completed cylinders. At the Grantham Works of Aveling Barford Limited, road roller wheels are made from 1.5-inch thick mild steel plate. Once the plate has been inserted, no further crane support is required, as the weight of the plate is taken by roller skates. The vicing rollers clamp the plate to the main roller, providing traction for movement of the plate through the machine. When presetting the edges of heavy plates for small diameters, the maximum loading of the machine is employed, and a shim is used to bring up the edge. The panel incorporates a micrometer screw for adjusting the stroke of the beam, and control for plate feed. The plate is moved forward, and bending will continue until the required curvature is formed. The curvature is measured. Concave templates are recommended when working with small diameters. Once the plate edge has been set, the controls are switched on cycle, and the bending proceeds automatically. The skates support the plate as it moves through the machine. The adjustable stop and limit switch control the actual stroke of the beam. The plate is fed a predetermined increment and is given the appropriate set or bend. This process is repeated, and progressive bending produces a smooth curve. To set the other edge, the machine is operated manually. The machine is quite capable of bending a plate to the finished diameter in one pass, but some operators prefer to bend it slightly larger and then bring it down to size in a second pass. Ultimately, the two ends of the plate will be seam welded together. Electro-slag welding, which must be done in the vertical plane, can be used for heavy plates after removal from the machine. With this machine, the rollers are lifted clear and the completed cylinder is easily removed. Now the machine tackles a 6-foot plate. Once the edge is preset over and the correct curvature achieved, bending proceeds automatically. This progressive bending principle is the main reason why these machines are less expensive than other rolls of equivalent capacity. The plate is not simultaneously bent and driven through the machine. Therefore, a high driving power is not required. Full power is only used when edge setting. The finished products. Tyres for the wheels of the world's road rollers. This is just one example of what can be produced in Hugh Smith machines. A 600-ton electric motor frame bender at work at the Loughborough works of Brush Electric. The power specified for the machines is based on the fully plastic condition of mild steel in the cold state. In practice, the plate bends before becoming fully plastic throughout its whole thickness. For producing a range of diameters, 3 or 4 sizes of interchangeable rollers are available. A built-in electric hoist is normally mounted over the rollers so that they can be easily changed. And the finished product, the casing of a flame-proof motor used in the mining industry. At Maver and Coulson in Glasgow, a support table is used on a Hugh Smith 8-foot, 150-ton universal bender employed in the manufacture of conveyor pulleys. Here, the spade method of presetting the edges of plates for small diameters is used to bring up the edge progressively. With this method, an extremely high local pressure is brought to bear on the plate edge. By moving the spade up and down, the edge is coined over very effectively. The plate has now to be bent to the required curvature. The correct stroke is set and the machine switched on cycle. It operates at a plate speed of 2 to 4 feet per minute, depending upon the length of feed per bend. In this case, a toggle-type kicker is used to operate the limit switch. On the same machine, a profiled roller is being used so that a barrel-shaped cylinder can be produced. Any plate within the capacity of the machine can be formed to a complete cylinder of, say, 36 inches diameter in about 20 minutes. This cylinder has a convex profile with a radius of 65 feet. Pulley drums like these for conveyor systems can be produced efficiently and economically on Hugh Smith machines. The finished product, a pulley with end plates. The machines may also be used to straighten plates as well as bend them. In conical work, radial lines are drawn on the plate to represent the amount of feed. This is at the Clydeside engineering works of John Brown. By using packing pieces, the position of the bolsters within their cradles is adjusted so that they taper towards each other at the top. Dual jib cranes can be mounted on top of the machine, where a fair amount of cone work is to be done. This eliminates the need for constant overhead crane attendance. After the initial preparation, the bending procedure is similar to cylinder bending, except that the plate must be realigned before each bend. The 2 edges are preset first, and bending proceeds. There are, of course, 2 templates, one for the top and one for the bottom of the cone. A center pointer is used to ensure that the radial line is truly vertical. The plate is fed forward by an amount equal to the spacing of the radial lines top and bottom, and the plate is bent. The finished cone, and a final inspection is made to ensure that the curvature at the bottom and at the top meets the required specification. Produced by a 12-foot, 1,200-ton Hugh Smith machine. For right-angle bending, a flanging bar is pinned to the main roller. For this type of work, the machine is operated manually. This is the 300-ton machine bending a plate 8 feet wide and half an inch thick. This is another example of the versatility of the machine. Here at William Neal, St Helens, a 1,200-ton vertical plate bender is employed producing cylinders for the gas industry. The 1 3/4 inch thick plate, 10 feet wide, is bent to a diameter of 13 feet 6 inches. A lifting beam is used to remove the large diameter cylinder, which is now ready for welding. Cylinders for these high-pressure gas storage vessels are produced rapidly on a Hugh Smith vertical bending machine. Here in South Africa, at the works of the Vanderbijl Engineering Corporation, a plate is removed from the furnace for hot bending. Most plate bending can be done in the cold state. However, when special circumstances demand red-hot bending, it can best be done on a vertical machine. When bending plates thicker than 2 inches down to very small diameters, such as those required for high-pressure boilers, hot bending ensures freedom from surface fractures. Strike while the iron is hot is literally true. Speed is vital. The plate is normally heated to 950 degrees centigrade, and then there is a working range of only 150 degrees down to 800 degrees centigrade, with the steel at a low yield point. A special alloy steel main roller is used for hot bending. It has exceptionally high heat-resisting qualities and eliminates the danger of breakage caused by thermal shock. The operator uses a jet of compressed air to blow away scale which drops from the plate. In horizontal rolls, this scale is often rolled into the surface, particularly undesirable when bending alloy steels. Because of the excessive heat, the operators applying the template wear aluminium asbestos cloth coats and leggings. Their heat-resisting hoods are fitted with special glass visors. Checks are carried out to ensure that the correct curvature has been obtained and the first bend is complete. The plate retains its working heat for only a short period, so before the second bend, the plate must be removed for reheating. Hot bending of heavy plates is a final example of the versatility of the machines Hugh Smith have been manufacturing for over 90 years. Their skill and experience in this field is acknowledged all over the world, where industries are benefiting from saving of capital, lower running costs and increased efficiency. Wherever the need is to bend steel, Hugh Smith can satisfy it.